So let's check it. It turns on and right away off. Okay. There will be a new fault, but it is your luck that what kind of fault we configure in this motherboard. Okay, the motherboard is in front of me, and it is, I think, 3000 model, yes, and it has this fan jack, and yes, oh my god, somebody has already reflowed this GPU and even the CPU and has applied a normal paste. It is not helpful, such unhelpful in condensing the heat from this board. So anyhow, we must check it. For this I always check first this chip, the biasings and the coupling resistors around this chip. This far relates with this section. So let's start. Okay, fine. All the resistors, the coupling resistors around this chip are fine. So I hope that this board is not ruined by anybody who have tried on this motherboard. Should be 47. Yes, and this one also we at 47 ohm and 100 ohm, 100 ohm. And here it is, if the cell is available in its socket, then this resistance value is at high value, 201. At low value, it should be at low value whenever the cell is present in its socket. Otherwise it should be at 4 point something K, and this should be at 33 ohm. Yes, fine. So the biasings are good. First of all, I must check for the short circuit in the power rails of these two chips, because somebody has used heat gun and tried to reflow these two chips. For this I must check for the RAM resistance and the even CPU resistance and GPU resistance and GPU RAM resistance. So for this I use my digital multimeter. Here you can see its reading as well. So it should be about 2 point something ohm, 3 ohm, fine, and it should be at 4 ohm or 2 ohm, which is at 2, and this should be at 240 ohm, 220 ohm. Okay, and this RAM power supply should be at 17 ohm, 21 ohm. The values are somehow vary, but no problem. It's mean this board can be fixed, and we will try our best to fix this board. Maybe for you there must be new kind of fault. So first of all, I will connect a ground with this motherboard. For this I have this wire, and at one corner I can connect it like this. Okay, and here I will need my workbench power supply. Here it is, and we need not ground anymore, the extra ground. So I will check it with the power brick. Yes, and here I need its power strip. And even the power source for this power supply. Here is my connector with on off switch, so we can connect it here, and yes, power on, and here is a red light, red steady light, and it is on and off. Now I will turn my oscilloscope as well on, and for you, hope you can see it. Now let's start from this power source. Yeah, oscillation is available, and on this power source oscillation is fine, and output volts you can check it, 1.8 volt fine, and here you can also check the output volts. It is too low level. Why? It should not be like that. Okay, this section is need to be investigated because it has not proper volts at these holes. Here must be 1.8 volt, but it is but 0.75 volts are available here. So at the back side of this circuit there is a feedback detector and DC to DC converter chip. This one, and we must verify the vicings around this chip. Here you can see that there are two feedbacks in this chip. One is from this power source, this one, and the other one is this power source. And this power source feedback is via this resistance, this one, this resistance, yes. And this power source feedback is via this resistance. This resistance should be at the value of 175 ohm. Yes, it's fine, as you can see. And this resistance, feedback coupling resistance, is 256 ohm, but it is 270 ohm. It is not good, maybe due to any other resistance in its way through this chip. So let's check these two. It should be 2.2 kilo ohm, and yes, it is. And it should also be 2 point something, yes, and this should also be 2 point, oh no, it is 11k. It should also be at 2.3 kilo ohm. And now finally test for this resistance. It should also be at 2.2 kilo ohm, but it is 4.6 kilo. So we have got the fault and configure it here that these two resistance, maybe one of these resistance is not good, but the two resistance are at their wrong values. So I will let you check again. This one, it should also be 2.3 kilo ohm, but it is, yes, it is 3.9 mega ohm, totally ambiguous. And it should also be 2.2 kilo ohm, but it's 4.6. Maybe this resistance, it is in mega ohm. We must replace this resistance. Okay, I will try to change only one resistor, this one. Maybe if I change this resistance, the all resistance value would be at their proper value. So if I get it on this motherboard, I got it. I will let it here and just move it away from this board, and here I will remove this resistance to replace it with this resistance, this one. So I got it at 2, and here I will go and place it here. Okay, let's check for the 1.8 volts that we need on this motherboard. Here I will go for the power on, and here is red standby light. I'm going to turn it on, and here you can see the oscilloscope too. I will put this probe on this point, if you can see it properly. So yeah, now we have got 1.5 volts, and now it is not turning off by itself. Processors are heating up. Maybe we can get the display, and here I should fix this metal plate so that it could not turn off by itself due to the overheat. And here is a red standby light. Now I'm going to turn it on. I should connect the jack, fan jack too. Yes, now it is steady, not turning off. And if we go to the display, yes, so guys, that was the story about this console. Somebody has already tried on it, reflowed both chips, but could not fix it, and hopefully it will be useful for you to get a new tip. And I'm happy that I have given you a new tip about a power rail that was not proper. So thank you very much and goodbye.